I got another stapler because how we've moved the classroom around. So I would request that if for some reason you use this stapler and know that it stays on my desk, that gray one, they're kind of the more expensive ones. And I did that so we can have a stapler living here and a stapler living over here. And we actually even have an extra one now because my classroom gets used for a lot. And I know a lot of people end up stapling stuff at the same time. So there was an extra one in the office, so I just asked, can I have this? And we have another stapler now, so that I can have one living on my desk. Homework. We are going to collect your homework next week. We're giving you this week off of collecting things, so I know people are trying to get mastered. Mastery deadline is tomorrow. If that's concerning to you, fix that. So, for those of you wanting to know the plan is over on the board right there. Where it says Math 8, I've got the whole week laid out. Because we're moving the quickest, this week at least, compared to like my other classes. So, Thursday is 3.2.2, right? We also have a couple people about to travel, so that's also why I put those up. Up through 3.2.2, right? Because if you did 2 days, that would give you to Monday. Up to 3.2.2, we will collect on Tuesday next week. So up through 3.2.2, we'll collect on Tuesday of next week. Now, what that also means, if you get all that done before like Friday, you could turn it in Friday if you want. But I see some people like filling in the rest of their plan book. Awesome. Now, one thing is I think my copies might have went to the wrong place because I keep making these here. So I don't have any future copies right now. But you can do this on graph paper. So you don't have to do it on the worksheets. I just give you those as like, it's easier when it's on the worksheet and right in front of you. And sometimes I add in graphs or add in whatever. But if you're really like, you know, I want to work ahead, I can't not do anything. I can't read my independent reading book because I just want, like, you can do it on graph paper. I have some people, like, really bugging me about handouts, and it's really just what's in the book. And sometimes I change stuff. So on your homework tonight, if you look at the bottom question on the front, this is a little different than what the book had because I rewrote it to, like, fit on the page. And it's essentially asking the same thing, but it's just, like, tweaked a little bit. So that's where mine is sometimes slightly different. And our worksheets sometimes have the class stuff. So our first problem for today is coming from the CC3 textbook, right? And it is 61. So I have this, but I don't love that. I'm actually probably just going to put the ebook up so I can change the zoom of the ebook. That's not... I don't know that everybody loves Dwight. I think that's probably an incorrect statement. All right, so you need out unnecessary. You need out your graph paper because all these questions are on your yellow sheet, but there's no space. Right? There's no space to process them. So Miss Kai's class is studying the dented square. Dented square. We know it's a square, right? And the shape is formed by removing a 1-unit square from the larger square. Right? So we took away a 1 by 1. Her students decided to let x represent the side length of the large square. So sure, we can call this an x squared. And y is going to represent the perimeter of the entire shape. Interesting. Y is going to represent the perimeter. So first thing we're asked to do is figure out what is y, what is actually the perimeter of the dented square, and then you're going to keep going down through here to make a table for the rule you found. We're going to process the area and the perimeter, but first, like the main thing they're asking us here, right, is perimeter. Then the table that we're going to create on your graph paper is going to involve, so I'll zoom out a little bit so we can see this, something called a boundary value. So start processing through this. I don't want questions, right? I mean, I'll walk around and I'll maybe answer some small questions. But the first thing you want to do is talk with your team to figure out how do we represent the perimeter of this since we don't know what x is. Right? Since we don't know what x is. Now, I was doing some quick copy pasting to try to get this on here. So you may have to look up here and write in x's and y's might be missing. So look at A Make sure that there's an X at the end of the sentence or write it in. Because I know there's some typos here. I just had to get these copies made for you. So in A, write in the X there. I got some people not with me, and I will have zero sympathy when I'm walking around and you're like, wait, what? There's a typo. Because I'm telling you right now. B, and it left gaps. It's this funky font that they use that, notice it won't highlight. It also won't copy. So that's why I just copied it and then figured we would write it in together. There's any time that you see like a gap, it's the X. Except for down here in F. So anywhere you see the highlighting, stop. That's what's missing from the page. I was continuing to edit this because I decided I wanted to put these questions in front of you guys so you could do it on the graph paper and not have to look back and forth to the screen. Oh, our notes are common graphing errors. Or you could just say graphing errors. But. So I want to give you guys like 5 minutes to try to process this. On
365, we're supposed to make a graph on a graph paper.
Why are we're not okay? We're gonna talk about those things, but why are you looking at 365 right now? No, we're doing 361 right now. But notice where it says this is your practice work, it also says you'll need graph paper. You're welcome. I typed that in there on purpose because I knew questions like that would happen. But you jumped into the problem instead of reading the directions. I got you, man. I'm trying to do this stuff to help you. But you're jumping in the middle of class onto reading your homework. Not what we're supposed to be doing. So F, this XY table, just everything we've been studying, it's a T-chart. An XY table is a T-chart. Right? What you've known in 6th grade is a T-chart. So I'm not going to leave these questions up here. Because I'm going to start to solve this a little bit, but I'm not going to write very much up here. You and your partners should be solving this on your own, right? Like with each other.
Should you do negatives?
I mean, what do you mean, should you do negative?
Can you do negatives? Like for the X?
For the X?
Negative.
Would the edge length be negative? An edge length can be negative? An edge length can be negative?
Yes.
No. Because, yeah, length, distance,
I'm not saying
all
in
those
this
things.
universe, but in
But
another
we're in this
universe.
universe.
And we're talking about this universe. Unless
You can say hi.
I didn't think I had to say what universe we're in, but
Well, in that case, I'm not solving that problem.
Guess we're not doing negatives.
What?
I'm so good.
so right now you're saying take away x minus 1. Oh, that's a plus. Okay. Yeah, okay, so you're saying this edge is x missing 1.
Oh, I figured out.
And then that cutout is a 3. Okay. So, making sure that nobody's confused, we're not doing area yet. We will eventually, with this object, do area. Like, you'll see the dented square again. But right now, we're just focusing on perimeter. So I have some really good thoughts happening. Give me just a second, Alex. If you look just at this edge, it would be x except for Audrey.
Well, technically, X is still there.
Okay, give me more.
If you just pull the 1 out, so that creates X again. You minus X and then you plus X. I mean,
So,
minus 1 plus 1.
perimeter. A lot of you had this written down. But I'll go ahead and like toot Audrey's horn for her, sing her praises, whatever. She's already thinking further down the road. This is more complicated than it needs to be. Audrey realized if I just move, oh look, I have the whole X now. But what we can't do is still count this because we just moved it. So that's gone. And Audrey said, I do still have that X. I do still have 4X.
And then plus 2.
And an extra 2. That's the same as this, though. It's the same. They're equivalent expressions.
Can you, so like, you could just simplify, like, can you just simplify, like, can you do that, like, with any, shape?
If you've written it out accurately, then yes. Yeah. So I want to make sure people heard this. I think sometimes you're like, your hand is up or you're thinking and you're not listening. This is the simplified form of this expression. The -1 and the +3 make 2. The 3x and the x make 4x. So this is our y. Now we also had the question, hang on, can x be negative? Who wants to talk to can x be negative? Alex? You had your hand up.
So, yes, x can be negative, but opposite. Okay, sorry. So, and negative x, so say negative x is 2. That means that regular x would be negative 2. So basically...
Hold on, you're misunderstanding the question. Not can we put a negative in front of x. That totally fine, sure, yeah. Here, can x be negative?
No.
Katie Ann, you look like you're about to explode.
Well, I want to say Mr. Hudson was very discriminating and did not put the question with universe in. So I want to say that if you did put a negative down, you are correct because you did not state what universe.
I'm not saying you're wrong.
You're wrong.
Oh, did I say the W word? No, I just said realistically. I said the R word. Audrey? Oh, sure.
You can't have a negative shape. So, like, with the,
Discrimination.
you can just say Audrey. Well, because, common sense.
Oh!
Common sense.
Be nice.
Common sense.
Hey, listen.
You can't have a negative shape. Like, even if you have, like, a little block, there's still perimeter. There's still a perimeter. If any of you guys can find out a way to make a negative shape, I will give you $1,000.
Wait, technically the air is a negative shape. The air is a negative shape because with a negative, nothing would be there. So technically the air
No, the air is a nothing shape. You're making a very 7th grade argument.
Oh.
So,
Painful.
Alex. Hey, respect our classmates when they're talking. When you get called on, you will probably feel bad if people are just carrying on whatever they were saying. Stop being rude. Alex.
Alright, so the reason why this particular shape cannot be negative is that looking at that shape, that's essentially what they took as an algebra tile and just cut a little thing out of it. And that's very clearly filled in. So that shape has to be filled in, has to be whole.
Oh yeah, he's right. Because all the graphs they showed the empty ones were negative. So
Can I use numbers to express this?
Now, also realistically, even when we think about the algebra tiles, those are a representation of a debt. So you still can, like, I know we'll say that's a negative tile, whatever. This is a positive tile, right? We all agree on that. Even if we talk about negative tiles, though, physically in our universe, right? I'll give it to Katie. She got me. I'm like, we're confined by our constraints, but on a different planet, in a different, like, who knows? But the geometry we're able to do, length or distance, right, cannot be negative. It just can't. It doesn't make any sense to us. Henry?
Scientists have proven that it's extremely likely that there is a multiverse.
Yeah. So I won't talk to any other universes. I'll just talk to our universe, right? I don't understand the other universes. So what you should be creating now is an XY table, either XY like this over, or XY vertically, to explore some perimeter values. What if X is insert something? Then what is the perimeter? So when X is X, we said our perimeter is 4X plus 2.
This is just for squares.
Right? This is just for what? This is for our dented square, the thing we're working with.
Oh, I thought I was. Yeah. Okay.
Are we good now?
Yeah.
Liam, question?
Well, I did, when I was little, me and my little brothers did a competition who could hit a baseball with a tee further. And my dad was measuring it, and I hit the tee and the ball went backwards. And he marked me for -2 feet. So I think that distance can be negative. There's a starting point, and you go backwards from the starting point.
So I've talked about that exact situation in
Yes,
class.
but that's 2 feet. You went 2 feet.
The ball went 2 feet.
Absolute
It
value.
went the wrong direction.
But it's
So
still
by your scoring system, it was negative. But that's like a value. It went 2 feet,
Wait, so
just
absolute
behind the tee. It's like absolute, yeah. Absolute value is what we use for distance and length.
Think about like a black hole. Wasn't that like the opposite of space? So since you have the opposite of the road, you can have the opposite of space.
I
and
can't
then you can
speak
have the
to the
opposite of
physics.
anything.
I can't speak to that. I just don't know. I don't
Here's
know.
what I asked this question.
Go work for NASA. Go work for Elon Musk. I mean, go do these things, but I don't know. Come back. Seriously. Skype me in, Google Hangout, be like, Mr. Hudson, I want to talk to your class and explain to them there are negative distances. I would love that. But right now, what we know, distance can't be negative. Right? Now we're going to move on from that. Last hand, no more that come up will matter. Henry.
Okay, but if you insert 1 into the equation,
Okay.
it doesn't work because there's a gap in the square that is 1. So therefore, it would never exist anyway because the gap would cancel it out, leaving it to be 0, and is therefore an exception to the rule.
Weird. So, hold on. He said it too fast for most of us to understand, but he said it accurately, right? What Henry just said is absolutely true. This is an object of unknown size, right? An object of that, I don't want to circle. An object of unknown size with a 1 cut out of it. So if my sides were 2, right, at some point, half of this side is removed, 1, 1, 1, 1, and like a 1 square is removed. Right, so what Henry said was if the sides are 1, if we allow x to be 1, then this 1 that we remove
Everything.
is this 1 that we remove.
Mind blown.
So X cannot be 1,
Wait, then S would be 2.
but it never says it couldn't be close, so it could be.
Now, my question to you would be, if the shape has no area, does that mean it has no perimeter?
Yes. Well,
No.
This gets into like theoretical math, right? Like, so what we get mathematically, if we plug in 1, is 6, right? Like we think we get 6? Question mark?
but if you actually do
But realistically, there's no shape left. But if I did this, and back that.
You get 6. But then you still
What if this is on the outside of the shape that doesn't exist, and now this is on the inside of the shape that doesn't exist? Now I'm having too much fun asking the what ifs. One doesn't exist, right? We know when we look at it, one doesn't exist. So solve values for larger than that. Just go up. I don't like whatever you're doing, smartboard. Let's try like 2, 3, 4, 5. I don't know. Try 10, something bigger. Just play with this for a minute. Find some values. What do you mean what?
That's so weird.
Life
Yeah.
makes no sense anymore.
So what Henry's saying is, it's only really weird if x is 1. Other than that, it's okay.
But does that mean for every equation there's going to be one number where it doesn't work?
Depends on if it's realistic.
It's like 0.
Depends on if it relates back to a physical situation. What if x is a half?
That wouldn't work either. But that would
Logan,
how
sorry,
does that
Henry.
work? It would
Logan's
create
hand has
void.
been up.
I think that if you x is 1, it would just be unfilled mesh. It would just have edges and vertices for no reason.
Yeah, but it would have to be 2-dimensional.
Yeah.
Yes, but then if
But
we
even
had
2D
it at
things that
half,
area.
it would create a void.
Yeah, I know, but it has to be 2-dimensional.
There's right here being a factor.
Other dimension.
Anything less than 1 would create a factor.
So I think we're gonna say this is like bad.
I love how this is for Mrs. Kai's class.
What about 2? If I plug in 2, what's my perimeter? 10.
Yeah.
Then I should be going up by
14.
4 every time.
God.
But we jump.
42.
Right,
They
so
said,
not only could x not be 1, could it be 3/4?
no.
Could it be a half?
It can't be
No,
anything
less than 1. If it's less than 1, then it's void.
Black hole. Negative, but then again, length and distance cannot be negative.
Therefore,
Black
if-
hole.
Here's where I get to teach you something.
Did I do something?
Please write down x is 4x plus 2, semicolon. Yeah, so those pencils that aren't moving, this is new. You don't know this yet. The semicolon is like a giant, what Mrs. Gordon was making fun of me for earlier, butt. I don't have a butt, right? I've been made fun of since high school. Swim team, they're like, dude, what? How does your body, what do you sit on? Quite frankly, I don't know. I'm just tall and awkward and whatever. This is butt. That's what that mathematical symbol means. So, y is 4x plus 2, but x cannot. Now wait, we don't want to say what x can't be because we don't like can'ts.
Yes.
What is x allowed to
Greater than
be?
1.
Charlie?
None
So
the
some of you were.
outputs left.
Hey, Bear,
Yes.
stop just shouting out. Notice how most of your class doesn't do that. Some of you said x can't be less than 1, which is true. But x also cannot be equal to 1. So we can't just say x can't be less. That's not accurate. X has to be more than 1. This is what we call, and I would like you to write this down, please, a domain restriction. This is what we call a domain restriction.
Couldn't you write the opposite of that? And
Yes, but when we restrict the domain, we talk about what is allowed to happen.
Isn't domain
So
related
think about when we're structuring our school, we would rather tell you what we expect out of you, like at Phoenix we do X, Y, Z, as opposed to saying you can't, you can't, you can't.
You can't.
So mathematicians would rather use the positive statement of what we can be. Now the other thing is sometimes there's multiple restrictions of x can only exist from here to here, and then it's allowed to exist from here to here, and then it's allowed to exist. There could be multiple of where we're allowed to exist. I got a lot of questions. I got to do one at a time. Avi.
Couldn't you just do x, well, not applying the can'ts, couldn't you still do x is less than or
equal to, or I mean, 1 is equal to, wait.
I mean, the only other way we could write this is saying 1 is less than the values of x, but we normally start with the variable to know what we're referencing. So yes, this says the same thing as this, but this is how we write it appropriately. And I'm trying to train you guys so like you're already ready for high school, college, all like engineering courses, all of that. Simon?
Does semicolon also function the same way in programming? So programming
I'm not sure. This is where you know more than me. Patrick?
So can you also do it? X can't be less than or equal to 1.
So this question has been asked. So guys, I love this class. I love how bright you all are and how you get in your head and you're thinking about something. But when we're talking as a class, you can't just zone out. Because this isn't about Patrick, this is about every single one of you, because this has happened to almost all of you where you've asked a question we've already talked about. Yes, we could say what x can't be. We could, but we don't. We choose, like mathematicians decided, it's better to say where x does exist. So we don't say, because the other way to write this would be x less than or equal to 1 can't exist. And look how gross that symbol is now. It's a slashed out less than or equal to. Like, we decided a long time ago putting the slash through for the cannot, it's messy. Right? We don't like messy things. We like efficient, clean things. So x is greater than 1. That tells you what you need to know with the least amount of effort. Alina. Who can tell Alina why x can't be 1? We talked about it. Hey, Bear, stop. Why do you take the rude road instead of just like, we'll help out our friend? That doesn't need a response. That's a rhetorical question. Do yourself a favor and just don't respond. This physical object, right? It's a physical object. They told us we had a box with side length x. That little box we know is 1. As long as x is bigger than 1, this can exist. Otherwise, poof, gone, unless it's in a different KDN universe. We'll call it the cat universe. The KDN, we'll just cut cat universe. Now, really, that would be stellar awesome if there was, like, a place we could go to where we could break all these math rules and do math in a different way. And that might, we might discover that. Leah?
And the question, is there anything that says, like, this drawing is to scale? Like, because if it is, obviously the 1 is smaller.
Yeah, we don't know what x is, right? This is saying x can be any number. So, hey, that was a good question. No. That's a good question, but Liam's stuck on like something I need to get us all unstuck on. If we don't know what something is, it can't be to scale. Because there's no comparing to scale. Right? There's no saying, well, x should be 5 times 1, because then we know what x is. X is 5. Right? There's no comparing scale here, because we don't know what x is. All right, we got to look at... man, we didn't even make a graph of this. So if we went to make this graph, I dropped a graph somewhere, but now I cannot find it. Oh, there's Dwight. All right, let me... If we were to make a graph of this, how we represent this. So throw a quick XY axis somewhere near what we just wrote. Near this that you wrote with the domain restriction. I'm going to write that again. Y equals 4x plus 2, domain restricted.
How big is the graph be?
Just big enough to throw a few points. Like it could be 5 by 5 and that's okay. Actually the Y will need to be higher than that. You could do 10 by 5, but the Y needs to be a bit bigger than the X.
So how tall does it have to be?
So you don't even have to make your graph yet. Just hang on to what we're saying. like just come with me, and then go back and do it on your own. If this is 1, and we'll say this is 1 too at that tick mark. We said 1 cannot exist, but if it were to exist, what value did we say it would have? 6, right? Because if I plug in 1, this would be 6. So we go to 1, 1, 2, 3, 4, 5, 6, but we're not going to put a point. We're going to put an open circle.
This is, you know how I feel? I feel like when you get all your Halloween candy in your purse, like looking into the basket. Like the suspension.
Now, don't write this down. I'm just trying to think of a way to describe this. When we put an open circle on a graph, it is a void. Actually, that'd be a better word than black hole, and it's easier. Hey guys, can I say a word like black hole without us flipping out? It's a void in our graph. It tells us that point doesn't exist. It can't. We've talked about why there's a physical situation we're trying to represent. So if we're trying to truly show this value with the shape we're representing, that point can't exist. And then we start our graph there. And we said our slope is 4. So then from there, 1, 2, 3, 4 over 1, that point would exist. 1, 2, 3. And then our line would start on the edge of that circle. So it touches that circle. And we're not trying to make the tiniest circle possible. What that means is at that intersection, at 1, 6, there's like a void, right? This, and I'll come to you, Liam, is what the lesson, I forget if we have the math notes box, nice and easy.
Woo! I made it pretty graph. Pretty boy graph. My dad made a graph.
Dude, I made whoa! It's triangular. That's weird. It's like circular.
All right, so now, just for sake of time, we're going to leave that at just saying that's a domain restriction. Jot down this table real fast, just so you have it on your paper. XY, just real quick, you don't need to be nice. XY, X goes 2, 3, 5, 6. X goes 2, 3, 5, 6. Y, are some people not writing, is my question. Y goes 8, 17, 35, 44. Again, Y goes 8, 17, 35, 44. Miss Kai's class put these in front of you. Now I am going to random card ask for who can tell me what's wrong with the graph. Okay? Yes. So these are the points they're supposed to be graphing. And these are the graphs the class made. Right? Because you're the smarty pants, you've been called to help the younger kids, and you have to help them understand what they've done wrong. We shouldn't need 5 minutes, but by the time this thing's about halfway done, we will start to random card. And no, I'm not taking any questions right now. You need to be talking to each other, analyzing these graphs.
No.
You can tell me now. So what's wrong?
Wake up!
No.
Now, well, really, once we stop our line, normally it doesn't pick back up unless there's a reason. Well, but it's a point that also doesn't exist. So what you're saying is true, but we don't put more things. We assume everything else is unless we grab any more lines. Then you might need another
I have another question.
Sure, as long as you put every word at the same time. Yeah.
What grade is Mrs. Kai's class?
It doesn't matter. That's an extraneous question that is unnecessary there.
They're not 7th graders?
There. Does that help you learn math? You are letting your brain focus on the silly 7th grade questions. Liam, what are you doing to that ruler? Are you trying to cut through your piece of lead? Oh, lost and found Dennis back there, right under the table. 30 seconds, we'll go over this.
No problem.
Not with these, it doesn't really work. To bridge these, so they're thicker in the middle than they are at the edge. So bridging doesn't really work, and there's some edges that aren't taped. So if you try to push them together, it doesn't go. One year I took actual playing cards and made these, but I realized I'm going to teach long enough, that's wasteful of playing cards. So I just use no cards to,
You never read what I like on my card. You called on me and then you read what I said on my card.
Sorry, are you wanting me to call you again now just because of that?
Yeah.
Well, here's Ellie's card. But that doesn't
You already read it for call for being smart or
Fun
whatever.
fact, if you shuffle a deck of
Can you
cards,
call me Ellie? I want to go up there.
Well, I don't know, I've never been created to hold. Katie Ann likes to read, write, color, swim, and read some more. It's that important to her. She wrote it down twice at the beginning of the year when we were getting to know each other. Which actually, after just being in class with Katie for a few days, it's pretty easy to tell she likes reading. So, Katie, you guys can pick your graph, I guess. 1, 2, 3, or 4. What do you want to tell us is wrong?
2.
Graph 2.
And they didn't start on 0. And if you're gonna start like that, you have to put the breakage thingy.
If the X and Y axes meet, that's 0, 0. If you're not gonna do that, say again what we do.
The breakage thingy.
We break it, right? We have to break the graph if we're gonna jump away from 0. But we still have to mark 0, 0 at that intersection. Avi, pick 1, 3, or 4. What's wrong with it?
3, I guess. The scales are not right.
The scale's not clear.
Yeah.
This.
It jumps.
We can figure out what they did though. Do you know why they put those numbers on the axes?
Because it's the numbers that are on the table.
It's the numbers they have. They just took the numbers from their table and put them on the axes. That's not how we scale an axis or an axis. We have to choose a scale and make that consistent. Xander, pick 1 or 4 to tell us what's wrong with it.
1.
What's wrong with 1?
We know, the scale, kind of.
Yeah, the x-axis goes by 8ths, quote unquote, and the y-axis goes by 2s, I guess.
Yeah, but we don't really have any other information,
Yeah, this one was a bit tougher to figure out what was wrong.
They also didn't
You
figure
gotta
out why.
compare it to the table.
They didn't think-
Josh?
they didn't figure out why values on the X.
This point, they switched around. So if we look at the point, that's 8-2, not 2-8. Right? Thank you for the assistance, Josh. And Audrey, bring us home. Number 4. What's wrong with it?
With Audrey.
Sorry, Hudson. It's by the cards, not. You were gone for a long time, and I didn't even have to worry about it. So you're back now. Your trip looked awesome. Are we going to show that to everybody at some point? I hope so. We can do it at forum or something. All right, real quick, we're out of time. Do you know what's wrong with the last one?
Yeah. So where the 2 is, it should be a 1, and then it should go on further because it doesn't match up with the scale for it to go from 2 to 0.
Yeah, if the scale goes by 2, they made 1 gap worth 2. Then they made 2 gaps worth 2, 2 gaps worth 2. They need another tick mark in here, right? They need to bump these all over. Y, 5, 10, 15, 20, 20. I think Y is okay. It's just the X.
No, it goes up to 0.4.
They only went up to 30.
Oh, yeah, they don't go far enough, but there's nothing wrong with the scale. It's just not big enough. Yeah, right. But then still, this is a different width than this. That still, it would look wrong. All right, that's all the time we got. We're actually over, so please pack up quickly.
Yeah, we are all. I'm leaving the ruler here.
Hey guys, I'll ruin the surprise. Gigi's the classmate of the day. In language arts.
What? Are you
You'll understand in a minute.
Oh, did you really name that food?
Yeah.